In this video, we'll look at some applications of exponential functions, also known as word problems. You deposit $5,500 into an account that pays 5%. What is the balance after 10 years if the interest is compounded quarterly and monthly? Okay, so first we recognize this is a compound interest formula, which means we'll need our compound interest. This is a compound interest problem, which means we'll need our compound interest formula. So the amount after time t is given by the initial amount, 1 plus the rate divided by the number of times it's compounded to the power of n times t, where t is the number of years it's invested for. Okay, so you may see that formula written a little bit differently in different text, but essentially it's the same thing. You might see different is that might be a p or some other letter representing the initial amount. Okay. All right, so if it's compounded quarterly and I'm investing for 10 years, then my function will look, before I plug in the 10, my function will look like this. $5,500, 1 plus, remember that as a percentage, as a decimal, 0.05, the decimal equivalent of 5%. Compounded quarterly, right? That gives me my value for n. That's 4 times a year is what quarterly means. And up here I'm 4 to the t. Okay, so that's my function where the independent variable is t. And now at this point I'm going to plug in my value for t, which I know is 10. Or we could have just done that all at once, but I wanted to first write it as a function. And now what I'm going to do is plug in t, because I'm evaluating the function at t. So what does that look like? Plug in a t and a t, and then it's just a matter of computing. Okay, and I'll use approximate because it's going to be a decimal value. All right, so in my calculator, what I do is I plug this in first, and then I raise it to the power of 40. Be careful to, if you're going to raise it to 4 times 10, to include those in parentheses, and then lastly I multiply it by 5,500. So see if you can get this value, $9,039.91. Okay, that's how much money you have after 10 years if your interest is applied 4 times a year. The next question is, what if it's applied monthly? All right, so it's the same function. The only thing that's different is how many times I apply the interest. So if I break up that interest rate into 12 and apply it once a month, do I really have that much more money? Well, let's find out. Okay, so the only thing that changed between A and B was the number of times the interest was compounded. All right, and if I run that through my calculator, I get approximately $9,058.55. Okay, so you see you do have more money because the interest is applied 8 more times throughout the year, but it's not that much more money. Okay, and we've seen this before. There is some kind of limiting property here, that the more you apply the interest, not necessarily the more money you're going to make. All right, now the next question I'm going to ask you is, what if it's applied continuously? The concept being that it's just always applied, always reinvested. So you have a different formula for continuously compounded. It's your initial amount, e to the rt. All right, so after 10 years, what if it's continuously compounded? I'm using base e. Up here the rate is the same, 0.05, and it's still 10 years. Should be more, right? But it shouldn't be that much more. So when you plug that through your calculator, you should get about $9,066, and I'll carry it out to the cents. Okay, so that's the idea that you've seen in your text, that the more you apply the interest, you're not necessarily going to keep making more and more money, that there's some kind of limit, right? And that's where this number E shows up. Part D, how long will it take to double your money if your money is compounded continuously? Okay, so we're sticking with this continuous formula, sticking with that function, but the question's a little bit different, right? How long does it take to double your money? In the previous three questions, I'm giving you the time and asking you for the amount. This one, I'm giving you the amount and asking you for the time, right? Those are my two variables, time and amount. So double 5,500, well, we could just multiply that, but it'd be 2 times 5,500 equals, and then over here I have my function. So let's translate that. I want to know how long it'll take for it to be double. Right here is the double amount, right? And t is the unknown. That's what I'm trying to solve for. So what we've done is set up an equation. Now this is different. The previous three problems were a little simpler. You just ran in t through the function and spit out your output. In this case, I'm given the output. I got to find the input, right? So I got to solve this equation. So we got to do our standard algebra. I'm going to divide both sides by 5,500. Not multiplying that out makes it a little bit easier to do that arithmetic, right? So I just get 2 on the left-hand side. 5,500 divided by itself is 1. Okay, so now I'm stuck. This is an exponential equation. The variable is up in the exponent, right? And we learned how to solve this. We're using this property. If y equals a to the x, then I know the equivalent logarithmic expression. The log base a of y equals x. Right? That's how we're solving exponential equations. Okay, so I got to apply that to this. So the first thing I realize is what I like to do is figure out what the exponent is. Right? In this relationship, the exponent is what the logarithm is equal to. So I'm going to go ahead and do that. The exponent, which in this case is all of that, is what the log is equal to. So I got to figure out what the log base is. If the base here is e, then my log base is also e. That's the natural base. And then I got to figure out what the input for the log is. The input for the log is the output for the exponential. Right? So it's really, I break that guy into three parts. Exponent, base, output. And I translate. Exponent, base. That was the output. It's now the input for my log function. Okay, so now really what I have is a linear equation. It may not look like it, but I'm trying to solve for t. So what do? I divide by the 0.05. So if I divide both sides by 0.05, that will give me my answer. And it should kind of make sense with the context of the problem. So if I plug that into my calculator, I get about 13.9 years. And I ask myself, does that make sense? Well, the money that I had to start was 5,500. I knew in 10 years that it got to 9,000. So does it make sense that in about 14 years that it gets to 2 times 5,500, which would be 11,000? So it kind of makes sense. I can do that little intuitive check to see that that answer seems to be on track.